The Buchanan tool was commonly used from the 1930s to the 1970s. The Buchanan tool was specifically designed to crimp Buchanan connectors, a type of electrical connector used to connect wires. The tool has two dies, one for the left side of the connector and one for the right side. The wires are inserted into the connector. The tool is placed over the connector and pinched together, crimping both sides simultaneously. There are several types of Buchanan connectors. Firstly, the Bulldog is a screw-on type with a built-in strain relief. Secondly, the Insulterm features plastic insulation with a built-in strain relief. Thirdly, the TP is a twist-on type without a strain relief. There are advantages of using Buchanan connectors. Firstly, they are easy to install. Secondly, they provide a secure connection. Thirdly, they are resistant to vibration and pulling. Buchanan connectors are still manufactured today but are less common than modern connectors like the Scotchlock and Nema connectors. Some electricians still prefer to use Buchanan connectors for certain applications, especially in older buildings where the original connectors were Buchanan. It's important to note that Buchanan connectors are not compatible with modern connectors, so it's essential to use the correct tool and connector type when making electrical connections. The Buchanan tool itself is a hand-operated crimping tool designed specifically for installing Buchanan brand electrical connectors. These connectors were popular for making reliable wire splices and terminations, particularly in industrial and commercial applications. The tool's design provides a consistent and secure crimp, ensuring a good electrical connection. Understanding the tool and its purpose is key to appreciating its historical significance and proper use. Let's delve into the mechanics of the Buchanan tool. It typically features two handles that, when squeezed together, actuate a set of jaws or dies. These dies are shaped to perfectly match the specific type and size of Buchanan connector being used. When the tool is properly positioned over the connector and the handles are squeezed, the dies compress the connector around the wires, creating a tight, permanent bond. The tool's design often incorporates a ratchet mechanism to ensure a complete and consistent crimp every time. This ratchet prevents the handles from being released until the proper crimping force has been applied. Different Buchanan connectors require different die configurations on the tool. Some tools have interchangeable dies that can be swapped out to accommodate various connector sizes and types. Others may have a fixed set of dies designed for a specific range of connectors. Identifying the correct die for the connector being used is crucial for a proper and reliable crimp. Using the wrong die can result in a loose or damaged connection. Buchanan connectors themselves come in a variety of styles and sizes. These connectors are designed for different wire gauges and applications. The most common types include butt connectors, which are used to join two wires together end to end, and ring or spade terminals, which are used to connect wires to screw terminals on electrical equipment. The connectors are typically made of copper or aluminum and are often tin-plated to prevent corrosion. The design of Buchanan connectors often incorporates features to improve the reliability and longevity of the connection. Some connectors have serrated barrels that grip the wires more tightly, while others have insulation grips that provide additional support and strain relief. Proper installation of Buchanan connectors requires careful attention to detail. Firstly, the wires must be stripped to the correct length to ensure proper insertion into the connector. Secondly, the correct size and type of connector must be selected for the wire gauge being used. Thirdly, the tool must be properly positioned over the connector before crimping. After crimping, the connection should be inspected to ensure that it is tight and secure. A properly crimped connection should be able to withstand significant pulling force without coming loose. Over-crimping can damage the connector or the wires, while under-crimping can result in a loose and unreliable connection. The Buchanan tool's widespread use from the 1930s to the 1970s reflects the importance of reliable electrical connections in various industries. During this era, electrical systems were becoming increasingly complex and sophisticated, requiring connectors that could withstand demanding conditions. The Buchanan tool and its associated connectors provided a robust and dependable solution for making these connections. While modern connectors have largely replaced Buchanan connectors in many applications, the Buchanan tool remains a valuable piece of equipment for electricians working on older buildings and systems. These older systems often rely on Buchanan connectors, and having the correct tool is essential for maintaining and repairing them. Furthermore, understanding the Buchanan tool and its history provides valuable insights into the evolution of electrical connection technology. The Buchanan tool represents a significant step forward in the development of reliable and standardized electrical connections. Buchanan connectors offer several advantages. They are known for their durability and resistance to vibration, making them suitable for use in harsh environments. The crimped connection provides a gas-tight seal, which helps to prevent corrosion and maintain a good electrical contact over time. The connectors are also relatively easy to install, requiring only a simple crimping tool. However, Buchanan connectors also have some limitations. They are not as versatile as some modern connectors, as they are designed for specific wire gauges and applications. They can also be more difficult to remove than some other types of connectors. Despite these limitations, Buchanan connectors remain a viable option for certain applications, particularly in older electrical systems. When working with Buchanan connectors, it is important to follow proper safety procedures. Always disconnect the power before making any electrical connections. Wear appropriate personal protective equipment, such as gloves and eye protection. Ensure that the wires are properly stripped and inserted into the connector before crimping. Inspect the connection after crimping to ensure that it is tight and secure. If you are not comfortable working with electrical connections, consult a qualified electrician. The history of electrical connectors is intertwined with the development of electrical technology. In the early days of electricity, connections were often made by simply twisting wires together. However, these connections were unreliable and prone to failure. As electrical systems became more complex, the need for more reliable connectors became apparent. The Buchanan tool and its associated connectors were part of a wave of innovation in electrical connection technology. These tools and connectors help to improve the safety, reliability, and efficiency of electrical systems. Today, a wide variety of electrical connectors are available, each designed for specific applications. Modern connectors offer a range of features such as insulation displacement technology, which allows for quick and easy connections without stripping the wires. However, the basic principles of electrical connection remain the same. A good electrical connection must provide a secure mechanical bond and a low-resistance electrical path. The Buchanan tool and its associated connectors help to establish these principles and pave the way for the development of modern electrical connection technology. The legacy of the Buchanan tool can still be seen in the design of modern crimping tools and connectors. Many modern crimping tools incorporate the same basic design principles as the Buchanan tool, using a set of jaws or dies to compress a connector around the wires. Similarly, many modern connectors use crimped connections to provide a secure and reliable electrical path. While the specific materials and designs may have evolved, the fundamental principles remain the same. In conclusion, the Buchanan tool is a significant piece of electrical history. Its widespread use from the 1930s to the 1970s helped to improve the reliability and safety of electrical systems. While modern connectors have largely replaced Buchanan connectors in many applications, the Buchanan tool remains a valuable tool for electricians working on older buildings and systems. Furthermore, understanding the Buchanan tool and its history provides valuable insights into the evolution of electrical connection technology. Remember to always prioritize safety when working with electrical systems and consult a qualified electrician if you have any doubts or concerns. Consider the wire gauge being connected and the amperage rating of the circuit. For example, if connecting 12 AWG wire, ensure the connector is rated for at least 20 amps to comply with the National Electrical Code, specifically Table 310.15b16. When crimping, ensure the tool applies sufficient pressure. A properly crimped connection should have a resistance close to 0 ohms. Use a multimeter to verify the connection's integrity. Ensure the voltage drop across the connection is minimal under load. A significant voltage drop indicates a loose or corroded connection. The connection should be able to withstand the operating temperature of the circuit. High temperatures can cause connections to loosen or corrode. Follow manufacturer's instructions for crimping pressure and connector type. Over-crimping can damage the wire, while under-crimping can result in a loose connection. Regularly inspect electrical connections for signs of corrosion or damage. Replace any damaged connectors immediately. Use appropriate strain relief methods to prevent stress on the connection. Proper strain relief will extend the life of the connection. When working with aluminum wire, use connectors specifically designed for aluminum. Aluminum requires special connectors to prevent corrosion. Consider using heat shrink tubing to protect connections from moisture and contaminants. Heat shrink tubing will provide an extra layer of protection. Always double-check the polarity of connections before energizing the circuit. Incorrect polarity can damage equipment or create a safety hazard. Use a torque wrench to tighten screw-type connectors to the manufacturer's specified torque. Over-tightening or under-tightening can damage the connection. Before making any electrical connections, review the relevant sections of the National Electrical Code. The NEC provides detailed requirements for safe electrical installations. Ensure all electrical work complies with local building codes and regulations. Building codes are designed to protect people and property from electrical hazards. When working on old electrical systems, be aware of potential hazards such as asbestos and lead paint. Take appropriate precautions to protect yourself from these hazards. Use a ground fault circuit interrupter, or GFCI, protected outlet when working on electrical systems. GFCIs protect against electrical shock. Be aware of the potential for arc flash when working on energized electrical equipment. Arc flash can cause serious burns and other injuries. Use proper arc flash protection equipment where required. Never work on electrical equipment when you are tired or distracted. The electrical work requires focus and attention to detail. If you are unsure about any aspect of electrical work, consult a qualified electrician. It is always better to be safe than sorry. The Buchanan tool is not just a tool, it is a piece of history. It represents a time when electrical connections were made with care and precision. By understanding the history and proper use of the Buchanan tool, we can gain a deeper appreciation for the importance of reliable electrical connections, and we can learn valuable lessons about the evolution of electrical technology. While modern technology has brought many advances, the fundamental principles of electrical connection remain the same. A good electrical connection must provide a secure mechanical bond, a low resistance electrical path, and protection from corrosion and other environmental factors. The Buchanan tool helped to establish these principles, and its legacy continues to influence the design of modern electrical connectors and tools. As electricians, we have a responsibility to ensure that all electrical connections are made safely and correctly. This requires knowledge, skill, and attention to detail. By studying the history of electrical technology and by learning from the experiences of those who came before us, we can improve our skills and provide our customers with the highest quality electrical services. In addition to its historical significance, the Buchanan tool also has practical applications in certain situations. For example, when working on older buildings that use Buchanan connectors, it may be necessary to use the original tool to maintain the integrity of the electrical system. In these cases, the Buchanan tool is not just a museum piece, it is an essential tool for the job. Furthermore, the Buchanan tool can be used to teach apprentices and other trainees about the fundamentals of electrical connections. While learning how to use the Buchanan tool, they can gain a better understanding of the principles of crimping and electrical bonding. This knowledge will be valuable to them throughout their careers as electricians. The Buchanan tool is a reminder that electrical technology is constantly evolving. What was once considered state-of-the-art can quickly become obsolete. However, the fundamental principles remain the same. As electricians, we must stay up to date with the latest technologies and techniques. But we must also remember the lessons of the past. By learning from the past, we can better understand the present and prepare for the future. In summary, the Buchanan tool is a fascinating piece of electrical history. It represents a time when electrical connections were made with care and precision. While modern connectors have largely replaced Buchanan connectors in many applications, the Buchanan tool remains a valuable tool for electricians working on older buildings and systems. Furthermore, understanding the Buchanan tool and its history provides valuable insights into the evolution of electrical connection technology. Always prioritize safety when working with electrical systems and consult a qualified electrician if you have any doubts or concerns. Remember that electrical work can be dangerous if not performed correctly. The Buchanan tool, with its robust design, underscored the importance of secure and lasting electrical connections. Its historical relevance remains significant, especially in understanding the evolution of electrical practices. Now, let's revisit NEC Table 310.16. This table details the allowable ampacities of insulated conductors rated up to and including 2000 volts. Ensure that the connectors, including Buchanan types, are rated to handle the specified amperage for the wire gauge. For example, a 14 AWG copper wire, often used for 15 amp circuits, requires a connector rated for at least 15 amps. Always double-check the connector's rating. Furthermore, ensure that the connector material is compatible with the wire material. Using dissimilar metals can lead to corrosion, undermining the integrity of the connection. For instance, aluminum wire requires connectors specifically designed for aluminum, often pre-filled with an antioxidant compound. This prevents oxidation and ensures a stable connection. Moreover, when working with any electrical connection, proper torque is paramount. Over-tightening can damage the connector or wire, while under-tightening can result in a loose connection and potential arcing. Consult the manufacturer's specifications for the recommended torque. If no specifications are available, err on the side of caution and use a moderate, firm tightening. The environment in which the electrical connection is made also plays a critical role. In damp or corrosive environments, use connectors rated for wet locations. These connectors are designed to prevent moisture ingress and corrosion. For example, heat shrink connectors with an adhesive sealant provide excellent protection in such conditions. Additionally, always inspect wires for damage before making a connection. Nicks, cuts, or frayed strands can significantly reduce the wire's ampacity and increase the risk of failure. Repair or replace damaged wires before proceeding. Consider using a wire gauge tool to ensure that the wire is the correct size for the connector. A wire gauge tool will help you avoid using a connector that is too small or too large for the wire.